Students, this is the third and final installment on the videos on factoring. Specifically, this one deals with factoring by grouping, where we take four terms and either separate it into a trinomial and a single term, or we separate the four terms into two binomials. I also put like a summation problem, or a capstone problem if you will, where there are many things you have to do to the one polynomial that I give you. Many types of factoring will have to take place on that one single problem for you to get it right. That will definitely be the separate the A's from the rest of the class kind of a problem, and it will be covered on your test. Let's examine group factoring a little more in depth. First of all, there's four terms you'll notice in this polynomial. This isn't your trinomial that I showed you. It's not your difference of squares or cubes that I showed you prior to that. This is completely different, and the only way you can do this is by grouping. You've got to make it into binomials or trinomials. Now, there aren't three terms, frankly, that go together. So this must be split into binomials, and I've literally, for no other reason, just divided it down the middle. I've taken the first two terms and called that our first binomial, the second two terms and called it the second binomial. Now, to be honest, if this method is going to work, it really doesn't matter so much how you split it up. There were other alternatives that would have worked just as well. In this case, however, what do my first two terms have in common? They both have an x. If I factor out the x, I'm left with a y in this term and a 3 in this term. Looking at the next two terms, they have a 2 in common. Once again, I'm going to factor out the 2, which will leave me with a y and a 3. Once again, please notice that both of my parentheses, the binomials, are identical. If you've done it properly, and this is indeed what you need to do, that must happen. Because the common term that these two terms now have in common is that binomial factor. I'm going to remove that y plus 3, and let's see what's left in each one of my terms. For my first term, if I take out my y plus 3, I'm left with just an x. For my second term, if I take out my y plus 3, I'm left with just the 2. So once again, I've arrived at my final solution. Y plus 3 times x plus 2. If I multiply the two binomials together using FOIL, which is always a good idea, by the way, that I've neglected to mention prior to now, multiplying them out should give you the original equation, and if it doesn't, then you have not factored correctly. Once again, we have a four-term polynomial, which means we're going to have to group. However, I want you to notice on this time that three of the terms do go together. The x squared, the 2x, and the plus 1 create a trinomial that can be factored. The y squared, if you will, is sort of the odd man out. So, if I group those three terms together and leave that y squared separated off to the side, do you notice that this is a perfect square trinomial? If you do, that's great. If not, you can still factor it. The x times the x would give me my x squared. Since my last term is positive, I know that both terms must be either positive or negative. Since this is a positive that I need, these terms must both be positive. So they both must be positive 1. And of course, if I check my inside and outside, I will get my correct middle term. If I rewrite this now as x plus 1 squared, it's exactly the same thing, but what I want you to notice is that I now have the difference of two squares. If I take off the squares, I have my first parenthesis, x plus 1 and y. The second parenthesis, or actually I've used a bracket for clarity here, is exactly the same, except instead of a subtraction, it's an addition. Finally, I went ahead and just simply removed the brackets because it's just easier for no other reason. I would give you full credit if you put this on the test, but it's just easier to see without the extra brackets. It's just two trinomials multiplied together that will indeed, if you test it, give you the original four-term polynomial that we had to begin with. My last problem can be thought of as a capstone problem. This is definitely one of those separate the men from the boys. By capstone, I mean it's the one that's kind of the summation of everything that I've shown you in this lesson. First of all, notice that I've started with a 4-term polynomial. Notice as well that there's many things that all 4 terms have in common. In this case, every one of these terms is going to have an x squared and a y in it. If I take out the x squared and the y from the first term, then I'm only left with my 5x's. In other words, if I remove 2 of my x's, I'm left with 5x's. If I remove my only y, I have no y's. For my second term, I'm not taking out a number, so the 16 remains. If I take out 2 x's, I have 3 x's. And if I take out the y, I have no y's. My next term, I am not taking out a number again, so it's -8. Taking out 2 of my x's leaves me with 2 x's. Taking out my y leaves me with no y. In my next term, I'm taking out the 2 x's and the y, so I'm left with only the 128. Now, take a look at the inside of the parentheses. Once again, I have 4 terms. I don't see any way to pair 3 of those together and be able to simply factor them. I suppose perhaps I could factor these first 3, but there'd be another term to factor out common, and it would just be messy, and if you look ahead, you can see that it's not going to come to a good conclusion. So I'm going to go ahead and do the more common thing, which is to separate it into 2 binomials. I have gone ahead and physically separated this time the first binomial from the second binomial. Looking at my first 2 binomials, or my first 2 terms, my first binomial, what do they have in common? They both have 3 x's in common. Now notice, first of all, I went ahead and just copied down the term that I factored out, and I'm now going to concentrate only on what's inside the parentheses. Again, these terms have 3 x's in common. If I remove 3 x's here, I have 2 x's. If I remove my 3 x's here, I have just a 16. Take a look at my second binomial. Once again, it's negative, so I'm going to need to remove that. There's no x's in common, but 8 is a factor of both coefficients. So I'm going to take out a -8. Taking out the -8 leaves me with an x squared. Factoring out a -8 from positive 128 leaves me with -16. Once again, as should be the case if this is going to work, I have the same binomial in both brackets, x squared minus 16. I will factor that out. Factoring out my x squared minus 16 from the first term leaves me with just an x cubed. Factoring out an x squared minus 16 for my second term leaves me with just a -8. And notice, I've just kept that original term that I factored out of the parenthesis to begin with. You keep it all along. It never goes anywhere. Now, on most problems, frankly, you'd be done at this point. But do you notice something about this particular problem? Look at the first parentheses. It's 2 terms. It's a difference. So the only way it could factor is if both of these are perfect squares. And they indeed are. This other one is also a difference. Since this is a 3 as a power and an 8, it can't be squares, but they are cubes. So in this case, I can rewrite this as x squared minus 4 squared. And this one as x cubed minus 2 cubed. So that you literally see it's the difference of 2 squares, the difference of 2 cubes. So let's go ahead and factor that out one last step. Again, I've left my x squared y out in front. The difference of 2 squares, I merely take off the squares for my first bracket. My second bracket is identical to the first bracket, but it becomes an addition. Now let's concentrate on the cubes. Taking off the cubes leaves me with my first bracket. The second trinomial is the tough one. The x squared gives me my first term. The -2 squared, -2 times -2, gives me my positive 4. The middle term of the trinomial is the product of the 2 in your original binomial. So 2 times x, or 2x. And remember to switch the sign. If it's a negative, the trinomial is a positive. And finally, you'll notice it's just multiplication throughout at this point. I would give you full credit if you listed the answer this way. But to be honest, you could just take off those extra set of parentheses. They don't really serve any purpose here.